Okay, girls, good morning. So I've decided to create a video for today's lessons because I know that a lot of girls are going to be away today. Some of you are going to be on Foodie, and some of you said that you were going to be away. And today is a very important lesson, so I decided that I wanted to do a video so we make sure that we all have the same information. We're still going to be using the notes. I'll tell you later which pages, and also the booklet, but I'll go to that later on. So first, please take out your notes book, and we are going to be working on solving equations by inverse or opposite of operations, okay? So, first, when we are solving equations, the objective or the aim is to leave the polynomial alone on one side of the equation equal to a number. So let's look at this equation. If I say x is plus 2 is equal to 5. So what is the value of x? So I'm sure that you're saying x must be equal to 3. The reason for x being equal to 3 is because x is the only value that x can take is 3 in order for this operation, this equation to be true. 3 plus 2 equals 5. So we just solved this equation by inspection. I'm sure that you have been doing things like this in primary school. But the thing is that not all equations are as simple as this one. So we are going to see today a method that can help us to solve any kind of equations. So let's look at this. What happens? When solving equations, we need to keep the following principles in mind. Girls, these are the three things that you have to always be very careful when solving equations. So the first one is, it is very, very, very important that we keep the balance of the equation. How do we do this? We do this by doing the same operation on both sides of the equation. Later on, we're going to do some examples when I'm going to demonstrate what I mean by this. The second principle is that we select which operation to do by undoing what have been done to the pronumeral. As I said, later on we're going to do an example and explain what it is. We undo by using the opposite operation. So we're going to focus on these two last ones here. Okay, so let's say that now I have a polynomial that is called y. And I say y plus 8. So I'm saying we select which operations to do by undoing what have been done to the pronumeral. So let's see. The pronumeral is y. What have I done here in this expression? I added 8. How can I undo this? By doing the opposite operation. What is the opposite operation of adding 8? So I'm sure you're saying take away 8. Exactly. So if I take away 8, what happens? I leave y alone. Perfect. Now let's do another example here. So let's say that now I have z. You know, girls, that I do my z a little bit different. So let's say that I have z. Take away 3 is equal to 11. Oh, sorry, I don't need the equal to. Just we're going to focus only on the expression. So z take away 3. Perfect. So if I want to undo what have been done to the pronumeral, so to the pronumeral, which is z, we're taking away 3. How do we do this? By adding 3. And if we do that, we know that take away 3 plus 3, this becomes 0. Therefore, now I'm undoing what happened to the pronumeral, and I have the z left alone. Going back to the previous example, I just want to say that when I have a positive 8 and I take away 8, this becomes a 0. Perfect. Okay, let's look at another example here. So let's say now that my pronumeral is called x. And let's say that I have 7x. Okay, so what operation, what are we doing here to the pronumeral x? We're multiplying by 7. How do I undo that one? By doing the opposite operation to multiplying. The opposite operation to multiplying will be division. Perfect. So I'm going to divide by 7. Right? And when I divide by 7, 7 divided by 7 will be 1, which means that I leave my x alone. So this one becomes x. Great. Now let's look at the following one. So let's say that in the following one I have 8 a divided by 5. I haven't done 5. Good. So what is being done to the pronumeral? We're dividing it by 5. How do I undo this? So I'm going to do the opposite operation of division, which is multiplication. And if I multiply by 5, what is happening? I multiply this one, and this becomes 1. So I have 1a. So this is equal to a. You may have noticed with what I just said that in the first two ones, what happens is that when I'm adding and subtracting, I get to a 0. So, and when I'm multiplying and dividing, I get to a 1. So just give me 1 sec. I want to explain a little bit more of this. So I want to go here. Why when I'm adding and subtracting it's important to get to a 0? So let's go back to basics. If I have a 3 and I want to add or subtract something that doesn't change the number, what can I do? Which number can I add or subtract to 3 so that it still maintains to be 3? I can add 0, agree? And if I add 0, I maintain a 3. Or I can subtract 0 and I can maintain my 3. So that's why when I'm adding and subtracting, I find that operation that cancels this up, what we did here. If I'm adding 8, I take away 8 and this becomes a 0. Okay, girls? But let's look at the other side here. So let's say that now I have my same 3, but I want to multiply a number that doesn't affect the 3, that doesn't change it. If I multiply a number, if I multiply by 0, if I do 3 times 0, I'll get 0. So I change the 3. I don't want that to happen. So I want the 3 to maintain the same. So what do? 3 times 1 is equal to 3. And if I have to divide it by a number, again, if I divide it by 0, 3 divided by 0 can't be done. So it has to be divided by 1. And it remains 3. Okay, so when I'm doing division and multiplication, I'm canceling and undoing this operation, doing the opposite to get to a 1. Okay, girls, I'm going to stop here because this is a long video and then I'll continue in part 2.